Okay, these notes accompany the 6-2 additional practice in the practice packet. For partial credit, copy only the notes. If you want full credit, in addition to copying the notes, I'm going to do the notes for the circled ones. You need to also do and show the work that goes with the asterisk mark problems if you want full credit. So let's take a look at these. So we've got this, they're telling us that this is a kite. Now, properties of a kite, the non-vertex angles are congruent. So angle A totally is going to be equal to angle C. The diagonals of a kite are perpendicular, and the big diagonal bisects the minor diagonal, the short diagonal. So these two segments are going to be congruent to each other. So because it's a kite, I've got these properties. Consecutive pairs of congruent sides are congruent, or consecutive pairs of sides are congruent, and the diagonals intersect at a right angle, and these the big diagonal bisects the minor diagonal, and the non-vertex angles are congruent. So all that stuff is true about this figure because they're telling us that it's a kite. So they want us to find out what the length of CD is. So here's a 21, here's a 20. This is a right triangle. This length is going to be the hypotenuse. It's going to be the square root of a squared plus b squared, which is 20 squared plus 21 squared. So that's going to be the, whatever the answer is, it's going to be the square root of 20 squared plus 21 squared. Okay, I'll leave that for you to work out. So get number 3, the measure of angle ABE. Here's angle ABE, this angle here that they're talking about. This is a right angle. This is a 51. That gives 141 degrees. Altogether in this triangle, they have to add up to 180. So 180 take away 141 comes out to be 39 degrees. So 39 degrees is the measure of angle ABE. We're actually doing 90 plus 51 subtracted from 180 comes out to be 39. These are all degrees. Okay, BCE, you want to find that one. Similar type steps. Oops. Let's look at number 6. Now here, they're telling us that we have a trapezoid. So if we have a trapezoid, then the bases are congruent, or the bases are parallel to each other, and the mid-segment is also parallel. And the length of this mid-segment is going to be the average of these two bases added up, or twice the mid-segment length is equal to the sum of the bases. So for number 6, they want us to find the length of XY. This XY length is going to be double these added together. So I'm going to add 3x minus 1 plus 8x and make that equal twice the mid-segment length, which is 3x plus 7. So again, for this one, we got base 1 plus base 2 divided by 2 equals the mid-segment for a trapezoid. That's our formula. So adding like terms, we get 11x's. On this side, take away 1 equals 6x's plus 14. Add 1 to both sides, take away 6 from both sides. 5x's is 15. Divide by 5, x is going to be 3. And it wants to know the length of each segment. XY is going to be 3 times 3 plus 7, which is 9 plus 7 equals 16. and you need to do 5 and 7. Number 8, we're going to fill the steps in on this proof. So let's see what we got. We're given that this is a kite, and we have an isosceles trapezoid. So with the isosceles trapezoid, this xy side, xy is parallel to WZ. I'm just making some notes. And we also have that AB segment is congruent to BC because of consecutive sides in a kite being congruent. And also we have that AD side is congruent to the CD side. This angle at A here, angle BAD, is going to be congruent to angle BCD because non-vertex angles in a kite are congruent. There's going to be a right angle at E, which means these are all going to be right angles, right triangles inside here. And what do we need to show? I want to prove that triangle ADW, which is ADW, which is this triangle here, is congruent to triangle CDZ, which is this triangle here. So I want to prove those two triangles are congruent. So let's see what we can do with that. Let's just kind of think it through without looking at the proof yet. So this AD side and AD and CD are congruent because by definition of kite, these are congruent sides. That gives us two sides that match in that triangle. If this is an isosceles trapezoid, then that means that the base angles are going to be congruent. Let's see what else we got. So right when I have an angle on the side, so this gives a side-side angle, which isn't good enough unless it was a right triangle. This major diagonal bisects the non-vertex angle, or bisects the vertex angle. I don't know if we can know for sure. It would seem like we could somehow get that these two angles are congruent to each other, but we would have to know that this was a right angle first. And we didn't really prove anything about this being perpendicular or anything to the midpoint. So we can't do that. This is the midpoint. Okay, if this is the midpoint of this side of this trapezoid, and no, it's not the midpoint though. Okay, I kind of looked through the proof a little bit, and what we need to do is get this angle here congruent to this angle, so we could do angle, side. And to do that, once we prove that these two triangles are congruent by hypotenuse leg, that's going to give us this angle congruent to this angle here by corresponding angles. And with this diagonal here being parallel to this base, which they're giving us in the diagram, we can do alternate interior angles and basically jump this measure down here, which will give us angle, side. So that's how this proof is going to end up. So let's see what they did here. So for number 1, we're given that ABCD is a kite. And also that isosceles trapezoid WXYZ. So I'm trying to make this look isosceles, keep them having to write it all out. Okay, AD congruent to CD. Definition of kite. kite has consecutive pairs of congruent sides. AD. I give us these two. Here we have that BD is perpendicular to AC. It's perpendicular to AC. Let's go ahead and put at E in here, just to be a little bit more specific. So we got that part. So we got right angle here, and there and there. ED congruent to itself. So we got that. Now this is going to be the leg. So that makes these two right triangles. This is a leg of the right triangle. And we just showed up here that we got the hypotenuse. This is the hypotenuse part of the right triangle. This part's going to give us the leg part of the triangle. So that's going to be where hypotenuse leg comes from. So this is reflexive property, ED congruent to itself. Reflexive property of congruence. Something's congruent to itself. By hypotenuse leg, then, we can say that triangle AED is congruent to triangle CED. That's going to be by hypotenuse leg. From that, corresponding parts is going to give us this angle, and this angle is congruent inside these two triangles. So those are going to be corresponding parts of congruent triangles are congruent. And then by alternate interior angles, with this being parallel. Now, with this being parallel, this AC parallel to WZ, that need to be up there in the givens somewhere. So I'm going to add this up here, that AC is parallel to WZ. That's all given. This is given in the diagram. It's not specifically listed out. But based on this being parallel, then we can use alternate interior angles and say that this angle WDA is congruent to angle EAD, and also angle ZDC is congruent to angle, how do I do this one? EAD, ECD. Those are alternate interior angles going this way and going this way, because these angles congruent to each other. So now we have angle, angle, side pattern. So it's going to be angle, angle, side. Transfer property of congruence, let's see. DAE is this one, and DCE is this one. So we're going to use transfer property, and that's going to leave these two equal to each other using number 6 and number 7. So we can say angle WDA is congruent to angle ZDC, which gives us the angle that we needed. The AD gives us the leg, or gives us a side that we need. And we need the other angle here. We need this angle W and angle Z. Angle W and angle Z. We have isosceles trapezoid, so let's see, somewhere in here, 3A. Angle W congruent to angle Z, and this would be base angles of isosceles trapezoid are congruent. So that's how we get those, and that gives us angle, angle, side. Okay, so we got that proof done. For number 9, in Bhutan, some of their buildings are in the shape of trapezoids. So they're basically telling you that the top base, one of the bases is 25 feet. The other base we don't know, so you have to find that. And this mid-segment length, they're telling us, which is the fancy brick, is 28.5. So AB plus EF equals twice 28.5, and you need to find out what EF is. So what's the length of EF? And this is in feet. So units also need to have feet.